All right, interval notation we've seen. It shows ranges of a solution for an inequality. But yeah, we are using parentheses sometimes, so I'll reiterate this. Just don't get those confused with ordered pairs. Do remember, though, that if it uses the parentheses, that means that those endpoints are not included. When I use interval notation, I do like to use a graph. Not all students do or need to, and that's fine. But I'm going to use the graph just as a visual representation. It helps me to put these intervals together. If a value is included, we'll have to use the square brackets. So yeah, values can go from negative infinity to positive infinity. We've seen that before. But since positive and negative infinity are not definable mathematically speaking, we can't include those. So if we see negative or positive infinity, we automatically have to use parentheses with those values. All right, so express this inequality in interval notation. So again, I like to see the number line here. To the left, I've got -3. I'm going to put the 0 in there, and then 6 would be something like this. So in comparison with just the -3, right? And you could even write this separately. You could say, well, -3 is less than or equal to x, and not worry about the 6, which may break this down into smaller, more manageable parts. And if that's you and it helps you, do it. If you don't need it, don't worry about it. But right off the bat here, I see that it could equal the -3. So at the -3, I'd have a closed circle there. That's not a very good one, but it still works. And that one's eating the x. Now, since this is a compound inequality, meaning we're also comparing x with 6, I'm just going to make this a small line showing it goes to the right, and because I want to see what happens with the 6. So the other part of that compound inequality was x is less than 6. So at 6, x cannot equal 6, so it'd be an open circle, which I can do a little bit better there. That one is not eating the x, so it goes to the left. So this means, and this inequality, by the way, was saying that x is everything between as well. So really what we just want is just one line between, like this. So it doesn't matter that the red inequality goes past this because it's limited at 6 through this purple inequality, or that the purple line would go to the left of -3 because -3 is the limit or the minimum based on the first part of the inequality. In fact, to emphasize that too, just think about values you could replace with x with to make this true. I mean, zeros, at least with a graph, zero's hopefully an obvious one, but 1 would work, 2, 3, 4, 5, or even like -2 or -1. All of those would work in between. But if I come over here and I say, well, I'm going to replace x with -4, it does make this part true, but it has to make both of them true. Since it has to make both of them true. This actually ends up being an intersection or and statement if you were to list these separately, but they do like to see these as full compound inequalities like this. Oh, I almost forgot to put this in interval notation. So starting at -3, which is included, so that'd be a square bracket, and then this would go all the way to 6, which is not included, so that would be in parentheses. That is the interval. Now again, I use the graph to do that. Not everyone does, and that's okay too. You know, that's a good point. So if the closed circles are going to force the square brackets, and then the open one, the parentheses. Yep.